For centuries, mathematics has operated on a geological timescale. Solving a single theorem often required decades of manual, isolated focus from a single mind. A little over a week ago, OpenAI announced that their unreleased Astra model successfully resolved 10 major problems across geometry, cryptography, and coding theory. We have moved past the era where computers simply processed our manual instructions. These systems are now acting as research partners, forming hypotheses and identifying patterns that humans have spent years searching for. The reaction was immediate. Right now, editorial boards at major journals are buried under an avalanche of AI-assisted submissions, while university departments scramble to keep up. When algorithms output novel proofs at this velocity, it forces the mathematical community to reevaluate what research actually is. This chart tracks math papers uploaded to the archive repository. From 1992 through the early 2020s, the data shows a predictable, steady climb. But recently, we see a vertical spike, correlating exactly with the release of advanced large language models. Funding agencies and peer review committees are actively racing to draft disclosure policies just to maintain a level of accountability in these submissions. If a machine constructs perfect examples or discovers a new proof, it is unclear who gets credit. Scholars are wondering what value remains in human creativity. This has triggered a crisis of identity. Working mathematicians are questioning the very purpose of a discipline, where a computer can reach the conclusion first. Mathematicians are split on how to proceed. Recently, Saul Friedman and his colleagues solved the decades-old semi-regularity problem regarding symmetric networks. From the start, Friedman refused to use artificial intelligence, citing the environmental and social impacts of the technology. The work was done entirely by humans. Contrast that with the approach of Aluna Rizzoli. He was exploring a complex mathematical structure known as the monster group. This visual compares the time spent on that problem. What had been a 2-year manual search was resolved by Rizzoli using an OpenAI model and a supercomputer in just 43 hours. Instead of publishing the discovery alone, Rizzoli used the results to foster collaboration, inviting the original researchers to co-author a joint paper. Both collaborations produced rigorous advances. The current tension revolves around methodology, not whether the results are valid. At the International Congress of Mathematicians, Terence Tao addressed this divide. He argued we must incorporate these systems to strengthen the field's culture and values. This sentiment is reflected in the Leiden Declaration. Signed by thousands of scholars, it argues that AI should augment human creativity with strict transparency and proper attribution. The focus has shifted from rejecting the technology to defining the rules for its responsible use. This creates an immediate problem for education. If software can compute any complex equation instantly, universities must decide how to teach foundational skills. There is a fear that the next generation of STEM students will lose their capacity for manual calculation. But the definition of mathematical education is changing. The core skill is shifting from the mechanics of a calculation to the ability to structure a precise logical query. Curriculums must focus on high-level logic, treating the AI as a tool that carries out the instructions provided by a human. The life cycle of a mathematical discovery now follows a new sequence. A human formulates the query, the AI generates a response, and the human performs the audit. That final audit is now the most critical step. Machines generate outputs, but they cannot verify the work or apply context to the answers provided. An algorithm can provide a potential proof in milliseconds, but true understanding still requires human judgment to act as the final filter. The mathematician's role has moved from the manual labor of calculation to the oversight of logic itself.